in the beginning by Dr. Walt Brown. Features to consider of the Grand Canyon on page 225. Colorado River. Actually, the puzzle is much more difficult. Geologists now agree that the Colorado River began flowing out of the Grand Canyon only recently. Here's why. Before the Glen Canyon Dam was built upstream from the Grand Canyon in 1963, the gritty Colorado River carried an average of 550,000 tons of sediment, sand, silt, and clay, out of the canyon each day, more than 5 tons each second. When the Grand Canyon, the Colorado River, west of the Grand Canyon, the Colorado River cuts through a 650-foot thick layer of Kaibab Limestone, whose topmost layers have been dated using radiometric techniques as less than 5,900,000 years old. If the river flowed through a lake that supposedly deposited if the river flowed through a lake that supposedly deposited this almost pure limestone, why are common river sediments not found in that limestone? Obviously, all that limestone was there before the river arrived. In geological terms, recently. How recently? According to most geologists, it was within the last 1,000th of the Earth's history. 3 different types of similar water-transported rocks are on opposite sides of the western Grand Canyon. Rocks that could not have been transported from one side to the other if the canyon blocked the way. Therefore, those rocks were present before the Grand Canyon formed and the Colorado River began flowing out of the western end of the canyon. Since 1934, geologists have been trying unsuccessfully to find a previous location for the river or to learn why the river began so recently. Kaibab Plateau. A quick look at a relief map raises another question. Why and how did the mighty Colorado River, flowing southward into northern Arizona along the east side of the Kaibab Plateau, suddenly make a right turn and flow west, up and over or through the high Kaibab Plateau? Rivers don't flow uphill. Desert view and overlook on the Kaibab Plateau just south of the Colorado River rises 5,800 feet above the river. Just across the river, the land rises even higher. All attempts to explain Grand Canyon try to answer this question. Some guess that the river was once a mile higher, and it flowed over and eroded a path down through the Kaibab Plateau, a process called superposition. Others say the river cut through the Kaibab Plateau along a fault, a crack. However, geological maps do not show that fault, and almost all faults in the region are perpendicular to the Colorado River, not parallel. Some believe that the land under the river somehow rose, forming the Kaibab Plateau, and allowed a river to cut through the rising plateau. 2 theories say that a stream flowing westward down a western slope of the Colorado Plateau continually eroded eastward 130 miles and eventually cut through the Kaibab Plateau, a process called headward erosion. Notice how these untestable explanations require millions of years to verify and provide no physics-based mechanism. Think how many untestable and therefore unscientific explanations we could fit into millions of years if those explanations didn't have to conform to the laws of physics. Missing Mesozoic rock. Actually cutting through the Kaibab Plateau is a relatively minor problem, and carving the entire Grand Canyon is not even half the problem. The Grand Canyon's rim consists of hard Kaibab limestone, typically 350 feet thick. When you walk on the canyon's edge to look down, you are standing on Kaibab limestone. It extends away from the canyon in all directions for about 10,000 square miles. However, Rising 1,000 feet above this Kaibab limestone at a few dozen isolated spots are softer, crumbly, or weakly cemented Mesozoic rocks. They are always capped on top by very hard rock, such as lava. That prevents the erosion of Mesozoic rock below. Obviously, lava did not flow up to the top. Lava which flows downhill collected in a depression and hardened. Later, a fast-moving sheet of water flowed over northern Arizona and swept all the soft Mesozoic rock off the hard Kaibab limestone, except for those few dozen high spots which were capped and protected by hard rock. Why was it a sheet of water? Falling rain would cut only channels. Flowing rivers or streams, even if they meandered for millions of years, would not uniformly sweep a 1,000-foot thick layer of material off almost all of those 10,000 square miles of the fairly flat Kaibab limestone. Besides, meandering rivers would produce meandering patterns. Therefore, before you can excavate 800 cubic miles of rock below the rim's Kaibab limestone to form the Grand Canyon, something must have swept off almost all the Mesozoic rock above, a much larger excavation project. Surprisingly, water also swept Mesozoic rock off the Kaibab Plateau. How could water get so high? As you will see, the sweeping event called the Great Denudation caused the Kaibab Plateau to bulge upward. Marble Canyon. To form the Grand Canyon requires first forming Marble Canyon, which is directly upstream, northeast of the Grand Canyon. The two canyons join where the Little Colorado River enters the Colorado River. John Wesley Powell, who led the first known expedition through the canyons in 1869, mistakenly thought the water-polished limestone he saw was marble, so he named the canyon Marble Canyon. Marble Canyon is a straighter, narrower, shorter, 61 miles long, and has steeper walls. The two canyons are like two adjoining pipes, and the explanation for one pipe should also explain the other pipe, even if they have different shapes. All the thin strata in and around Marble Canyon tip in directions that form curious but consistent pattern. People floating southward inside Marble Canyon sense they are rapidly falling. An optical illusion causes that sensation because the strata inside the walls of Marble Canyon tip up to the south. So as one flows downstream, one rapidly moves past lower and lower layers in the narrow walls to the immediate left and right. Relative to a fixed point on the ground, one is only dropping about 8 feet each mile, a hardly perceptible rate. If we look closely, we can see that the layers in Echo Cliffs to the east and Vermilion Cliffs to the west tip up toward Marble Canyon. At the southern end of these cliffs, the layers also tip up to the south toward the Grand Canyon, 30 miles away. See figure 129 on page 233. Later, you will see the rapid removal of dirt that formed Grand and Marble Canyons caused the surrounding regions to rise, just as removing one book from a stack of books resting on a spring scale will lift the remaining books. Another unusual feature of these cliffs and others in the region is the lack of rubble, called talus. At the base of the cliffs, if freezing and thawing cycles acted for millions of years on the cliff faces, a sloping pile of loose rocks would be at the base of the cliffs, even if the cliffs were young. Lifting or carving cliffs should have left considerable talus. The Great Denudation, time or intensity. In 1882, pioneering geologist Clarence Edward Dutton showed that almost all Mesozoic rock, at least 2,000 cubic miles, had been swept off about 10,000 square miles of fairly flat Kaibab limestone before 800 cubic miles of deeper rock could be excavated to form the Grand Canyon. To appreciate these volumes recognize that all the water in the Earth's rivers totals All the water in the Earth's rivers totals only about 300 cubic miles. Dutton called this sweeping event the Great Denudation. He assumed that so much erosion required a very long time, but he overlooked another possibility: lots of violently flowing water spread over a wide area for a short time. Few people realize that the Grand Canyon can deepen only when the water flow is violent, because up to 75 feet of silt, sand, gravel, and boulders cover and protect the bedrock under the Grand Colorado River. The river cannot scour that bedrock and deepen the canyon unless a violent flow removes the blanketed debris. Even before Glen Canyon Dam was built, periodic floods produced little bedrock scouring. What caused such a violent surge? And figure 129 on page 233. Oh, look at that. Boy, that's nice. Figure 129 on page 233. 129. There we go. Page 233. Tipped cliffs. Looking southward from Antelope Pass Highway, the catastrophic breaching of Grand Lake carved the funnel and removed so much vast that your eyes can easily see that the land below bulge upward. Including the land below. Oh, wait a minute. So much mass that your eyes can easily see that the land below bulge upward, including the land below the newly exposed cliffs bordering the funnel and below Marble Canyon. Why quickly? As you read Plateau Lift on page 236, you will see that immediately after the flood, frictional heating from the sinking Rockies produced magma that was injected between the former floor and roof of the subterranean chamber, lifting the Colorado Plateau. Therefore, for every ton of rock and water later removed by the breaching of Grand and Hopi Lakes, a ton of liquid magma immediately shifted directly below the eroded region, preserving the vertical force equilibrium and upwarping the Kaibab Plateau. This is called the water balloon effect. See figure 34. Oh, we'll get to that later. Okay. All 40 miles of surrounding cliffs arched up toward Marble Canyon, producing the Big Crack. Although Marble Canyon is 2 to 5 miles away. For perspective, note the houses at the base of this portion of Echo Cliffs, marked by the yellow dot in figure 128. Most rubble called talus is missing from the base of the 40-mile cliff system because the water spilling out of Grand Lake and its banks for weeks swept the rubble away, and this happened only a few thousand years ago. New rubble has not had time to accumulate. So figure 128. Where are we at here? Oh yeah, here we go. Figure 128. That is going to be the yellow dot, the Big Crack. The house at the base of this portion of Echo Cliffs marked by the yellow dot. Okay, on figure 128. There's a house down there. Figure 128. Where is the house? Okay. Aerial photograph of the funnel and the backward barbed canyons. The dashed white line shows approximately where Echo Vermilion Cliffs were connected before Grand Lake breached and eroded the funnel. This was confirmed during my field work by finding a long, dramatic fault marked by the solid red line, shown in figures 151 and 52 on 261. Note this cliff system was parallel to the other northwest to southeast cliffs in the Grand Staircase to the north. All were formed as Grand Lake to the northeast drained through the funnel. That steady removal of the weight of the lake's water was equivalent to a growing upward force lifting the bottom of the draining lakes and producing a series of shearing failures. Each shearing failure raised one of the steps in the Grand Staircase, and Echo and Vermilion cliffs. The higher southwest-facing cliffs steps in the Grand Staircase rose as Grand Lake and Hopi Lake drained. The more subsurface water spilled out of those cliffs faces during the Great Denudation, and the more erosion occurred southwest of each step. Figure 452, page 245 will give you a feel of the massive Grand Lakes waters. Okay. And then he referred to figure page. This is called the water balloon effect. Okay. As you remove for every ton of water removed from the breaching and lakes, a ton of liquid water immediately shifted below the eroded region, preserving the vertical equilibrium, called the water balloon effect. Let's take a look at that. There it is. The water balloon effect. What upwarped the Kaibab Plateau? Most of us have squeezed balloons filled with water and watched the least compressed sides bulge outward. Immediately after the compression event that buckled up the Rocky Mountains, friction and pressure from the sinking Rockies melted rock and injected magma into the thin pre-existing channel between what was the subterranean chamber's floor and ceiling. The magma acted as the compressed liquid in our balloon. Water erosion and drainage removed weight at certain locations on the Colorado Plateau, so the magma's pressure directly below those regions dropped. Therefore, more magma flowed in and bulged the crust and upward like a water balloon, producing more water erosion drainage and the Kaibab upwarp. This water balloon effect also accounts for the dramatic upwarping of the crust under what is now Marble Canyon and Grand Canyon, because the breaching of Grand Lake and Hopi Lake removed sediments and weight. Figure 129, figure 130, and 123 and 24, and figure 151 show this upwarping of the grand water balloon effect. Upwarping also produced deep vertical cracks that grew from the Earth's surface down through the water-saturated sediments, allowing water to escape and removing sediments and weight. So the magma under the crust shifted to bulge up the Kaibab Plateau even more, like a compressed water balloon. Geological explanations often lack a clear identification of forces, energy, and mechanisms. Obviously, millions of years is not an explanation or mechanism. The mechanism that produced the Kaibab upwarp was the water balloon effect. Can you identify the forces and energy? Well, the force would be gravity. Okay, let's take a look at some of these features. Oh, yeah. The upwarping. The water balloon effect. Yeah. Wow. And then 237 again. And finally, figure 151. Wow. Fascinating. So that's some Grand Canyon effects from In the Beginning by Dr. Walt Brown.